Good evening, class. We are starting with Intro to Ratios. Please take out your notes. And we are going to start with a ratio is a comparison of two numbers. It can be written three different ways. We're going to use the pictures below to practice writing ratios. First one we're going to do is teeth to no teeth. So we're going to count up all the pictures that have teeth in them. I see 1, 2, 3, 4, 5, 6, 7, 8, 9 teeth. 2, we're going to use two colons, not two colons, a colon. 2 dots like this is a colon. To no teeth, well, we count up the rest of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this is our ratio. Now, a lot of times when we write ratios, we want to simplify that. So I know I could divide each of those by 3. So my ratio could also be 3 to 5. Okay? So next one we're going to do is smiles to total. How many smiles do you see? I see 1. I see 2, I see 3, I see 4 whole smiles. To how many total? How many are there all together? There's 24. I can also rewrite this 1 to 6 by simplifying. Okay, next one we're going to do is tongue to total. Tongue to total. So I see 1, 2, 3, 4. I see 4 tongues to total, which is the exact same that we just did. That's also 1 to 6. Angry to smiles. Ooh, I see lots of angry faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, there's 12 angry faces to only 4 smiles. If I simplify this, I can divide both by 4. I get 3 to 1. So there are 3 angry faces to every 1 smiley face. Okay, how about big eyes to teeth? Big eyes to teeth. Count them up. You should get 12 big eyes to 9 teeth. I can simplify by dividing by 3, so I get 4 to 3. This means for every 4 big eyes, there are 3 teeth pictures. Smiles to tongue. Well, I have 4 smiles to 4 tongue, or 1 to 1. I have 1 smile to every tongue sticking out. Silly face to angry face. There are 12 silly faces and 12 angry faces. This is also 1 to 1. How about tiny eyes to no smile? Ooh, tiny eyes to no smile. Count them up. You should have 10 tiny eyes to, oh gosh, lots of 20 no smiles, which is a 1 to 2 ratio. The order in which you write your ratio is important to the meaning. I couldn't switch and write no smiles to tiny eyes because that's not what it asked me for. So when we look at this, teeth to no teeth, very important. I'm going to write that 9 to 15, right? Because that's what I found right here. But if it says no teeth to teeth, it's 15 to 9. It makes a difference. Order is the most important thing when it comes to ratios. Okay, question number 1. In the lunchroom, there were 100 chocolate milk cartons at lunch. When lunch was over, 88 had been purchased. What is the ratio of number of milk cartons purchased to total number of milk cartons? So when I write this, I need purchased to total. It is super important that you write words first. What was my total? 100. How many was purchased? 88. So it is 88 to 100. You can simplify that by dividing by 4 to get 22 to 25. What is the ratio of the milk cartons remaining to the number of cartons purchased? So I have a little bit of math to do. I have remaining to purchased. Purchased, I know, that was up here. There was 88 of them. How many were there remaining? Well, if I started out with 100 and I had 88 purchased, that leaves me with 12 milk cartons. So now I have 12 to 88, or I can divide by 4, and that gives me 3 to 22. Okay, using your pencil and a clip, spin the spinner 20 times. Mark your results. How many A's do you get? How many B's do you get? You're going to rate your ratio. You're going to tell me what happened if it was 1 to 4. What do you need to do for 3 to 1? And create different ratios from your experiment above. If you don't have it, I don't know, write them on cards. I don't know, if you have a dice at home, 6 sides, just 1 is A, 2 is B, 3 is, whatever it is, do something 20 times, figure it out. Okay? And then ratios can be simplified. This is the big thing here. And it makes more sense when they're smaller than bigger. So that we like to simplify. You know, math teachers, we like to simplify anyway. Okay, so we're going to practice simplifying these ratios. What can I divide this one by? I'm hoping you're all shouting 3. And so I do that to this one, and I get 1, 2, 2. How about, and you notice ratios can be written 3 ways. And I didn't talk about this earlier. You can write them with a colon. You can write them as a fraction, and you can write them as the word 2. Most of the time, we use them as a fraction, just so you know. You'll see this one a little bit. Rarely do we use this one. We usually use a fraction. So you're going to finish summarizing, and then you're going to give me that beautiful 2 to 3 sentences. Okay? We actually have 2 parts to this lesson, so we're going to move on. We're going to do this page as well. And this is ratios as comparisons. So a ratio is a multiplicative, ooh, that's a fancy word, multiplicative comparison of 2 quantities with the same attribute. They can be written 3 ways. Multiplicative means it's a multiplication problem in there, right? Yes. So dogs to animals, students to teachers, red marbles to blue marbles. Ratios that are equivalent can be simplified to the same value. For example, 4 to 5, 8 to 10, 12 to 15, all can be divided back to 4 to 5. 1 6, 2 12, 3 18s, all can be divided back to that 1 6. So I'm going to show you how to create equivalent ratios. The first thing I'm going to do is multiply by 2, and I'm going to get 14 to 22. Then I'm going to come back and multiply by 3. 7 times 3 is 21. 11 times 3 is 33. Okay, what about the next one? Same way. And how about this time, instead of multiplying, I'm going to divide. I'm going to divide this by 2. I get 9 to 6. What about if I divide it by 3? I get 6 to 3 is 4. Good job. Okay, how about here? I could divide this one by 2 and get 3 to 5. And then I can't divide again, so I could double this or multiply by 2 and get 12 to 20. There's lots of different choices here when you're making equivalent fractions or equivalent ratios. They are equivalent fractions in case you haven't figured that out as well. Determine if the ratios below are equivalent. If so, determine the multiplier or scale factor. Well, how we do this is we're going to check this and we're going to go, what do I do to 5 to get to 20? And my answer is multiply by 4. Do you do the same thing here? 2 times 4 is 8. So yes, this is equivalent. And the scale factor is times 4. Okay, how about this one? I can't do, what do I do to 3 to 4? But there is another way I could do this. I could go like this. 3 times 4 is 36. And I can go like this. 4 times 6 is 24. Are these 2 numbers equal? No, not equivalent. We do not use this method when we add or subtract fractions. We only use cross multiplication during this process when we're determining if they're equivalent or we are using proportions and trying to find a missing variable. Very bad math if you use that in fractions. How about this one? Can I go 6 to 15? Not easily. So I'm going to go this way, and I'm going to get 120. And I'm going to go this way, and I'm going to get 120. And yes, they are equivalent. They do not have an easy scale factor, though. So what I have to do to figure out that scale factor is I actually have to divide 6 by 50. No, I got to do it the other way. Sorry. Where's my backup? Okay, I want to do 15 divided by 6. 6 goes into 15 2 times. That gives me a 3, bring it down, and I get 2.5. This is my scale factor, so I have a scale factor of 2.5. Okay, Audrey and Megan are decorating for a birthday party. Audrey hangs streamers in the same amount of time, 4 streamers in the same that Megan hangs 6. If Audrey hangs 12 streamers, how many will Megan hang? There is a tape diagram and a proportion to solve. So, Audrey hangs 4 streamers in the same amount of time that Megan does. So Audrey hangs 4 for everyone that Megan hangs 6. And so here, if Audrey hangs 12, well, how many does she hang each time? Well, 4. So we're going to divide that into 4 pieces. So each time she's going to have 3, 6, 9, 12. Now Audrey's hanging 6 each time, so she's going to get the same 3, 6, 9, 12, 15, 18. So this is Audrey, and she hangs 12. And this is Megan, and she hangs 18. Let's see if that's true. Audrey's going to hang 12 streamers. What do I do to 4 to get to 12? Correct. I multiply by 3. Whatever I do to the top, I do to the bottom. 12 times 3 is 18. So we have a scale factor of 3, and she hung 18 streamers. Okay, Sally's summer punch recipe is a combination of lemonade and fruit punch. Sally uses 6 cups of lemonade and 8 cups of fruit punch. Use the ratio to complete the chart. June made a recipe of, so first of all, we have this. She has 6 cups of lemonade to 8 cups of fruit punch. That is important. Okay, once we have that, we can actually simplify this. We can divide by 2, so I get 3 cups of lemonade for every 4 cups of fruit punch. So Jane is going to create this lemonade to fruit punch recipe, right? And, June has 21 cups of lemonade. So how many cups of fruit punch does she need? Well, our original is 3 to 4. So I'm doing 21 to what? What do I do to 3 to get to 21? Times 7. So whatever I do to the top, I do to the bottom. So you should have 28 cups. This is 3 to 4 in simplest form. Was Sally's recipe used correctly? Yes, because my ratios are the same. Yes, because the ratio of lemonade to fruit punch is the same. Okay, how about I'm going to do August. So he did 35 cups of total liquid. So I have total to 15 lemonade. So we have lemonade to total. So lemonade to total this way looks like this. So my total here is 3 to 4. So I have a total of 7 in the original recipe, and lemonade should be 3. right? Because 3 plus 4 is 7. That gives me my total. And then I can figure out 35 cups. Well, 7 to 35 is what? Times 5. Lemonade times 5. I would need 15 cups of lemonade. Is that what they used? Yes, indeed. My ratio is the same. Yes, because 15 to 20 or 15 to 35 reduces to the same ratio. Okay, I am going to ask you guys to finish these last 2 questions, and to make sure you summarize, give me 2 to 3 really good sentences here. I will see you in class tomorrow. Sorry this is so long, but I think you guys can handle it. Have a great night.